Hey, hey. You muted.
Can you hear me now?
Yep.
Hello.
When
Morning. Let's give folks a minute or two to join. All right, let's get started. So today we're going to talk a bit about Teuthology and Ceph testing in general. Try to give you guys an overview of what Teuthology does, how you can use it to run tests, and how to looking at test results. So I guess the basic we can start off with is Teuthology is based around testing packages currently. So the first step to getting anything tested is to push a branch of the Ceph.git repository to github.com/ceph/ceph-ci, and any branch there will automatically get sent to shaman.ceph.com, which will go ahead and kick off builds and generate packages for CentOS, Ubuntu, in different combinations that we need to run tests on them. You can see kind of the latest packages and builds going on over at shaman.ceph.com. And once those are finished, you can click on any of those and it'll end up seeing log output if something fails. And after the basic builds are done, packages are created out of those. And you'll find those under the repos URL of Shaman. You can kind of look through and see if you wanted to download those manually, you could actually go and find the URLs for the individual packages. But in practice, you don't need to worry about that. You just push your branch to FCI, wait until the repos are built, and then you can start running Teuthology dabs, which go and grab those packages. So for Teuthology, testing stuff, basically for most changes in Ceph, before we merge PR, we will batch things up into a test branch, push this FCI, wait for it to build, and then kick off a test suite launched by Teuthology. Basically, all you need to launch a test suite is a checkout of the Teuthology repository. You can see that one of these on connected to the CP lab on the Teuthology.ceph.com machine. Even take a look at my home directory and see how things are set up there. But basically, on that machine, there's a simple machine-wide etc Teuthology.yaml file, which contains all the settings needed for it to connect to the lab cluster and schedule jobs there. So once you've got Teuthology checked out on that machine and your branch is pushed to FCI and packages are built from it to run a suite, you're basically just running a Teuthology suite command and specifying which branch it should run based off of. And it'll add a bunch of jobs to a queue, which you'll find in, there's a web interface for that at pulpedo.ceph.com. Take a quick look around there. Share my screen so we can take a quick look through that. So Pulpedo has a number of, a kind of an overview of both the jobs that are scheduled as well as individual suite runs. So you can take a look at the current queue, and you can see these are various suites that have are in the queue right now. The queue is very simplistic. It just runs based in order with a priority field, and you can see who scheduled these jobs. All these ones scheduled by Teuthology are just automated runs scheduled via cron. And in the CPO lab, we have a few different types of machines that might be used. We have Smithy, which are kind of fast LSSD machines, OVH, which is virtual machines in the OVH cloud, and also Mira machines, which are older hardware, all hard disks. So if you go and you can also kind of look at past runs in Pulpedo. You can filter out past runs, for example, by suite. If you wanted to look at all of the say runs of the RPD suite, you can go there, and you can even just change that URL to specify the suite parameter that to whatever suite you're looking for. Drill down into the results of a given suite. So, for example, this one, you'll see the results of each job. For the results of all the jobs are stored in the CPA cluster. There's actually a CephFS file system that's holding all of the job results, but you can also access them through this web interface here. If you go into one of these failed jobs, you'll have links to the Teuthology.log, which is basically the output from the in-test run, and within that same directory, Teuthology will collect all of the logs from the Ceph cluster, which includes all the daemons and everything else that's running there. You can go and inspect any like core dumps or any other kinds of test output. So if we go on a Teuthology machine, these are also accessible directly from that CephFS file system. And the CephFS file system with holding all the results is mounted on the Teuthology machine under /A. So you find this exact same job by going to the Teuthology machine /a/the description of the suite, which is always like the user who's running it and the date and the other parameters. You can see from the web interface, and then you can go and inspect the individual jobs there. So when we were looking at in Pulpito was, let's see, 2836925. So we can just go into that directory and check out what is here. So one of the important bits here is the orig.config.yaml. This is exactly what was what the configuration that was basically passed to as this Teuthology job originally, before Teuthology kind of added extra internal things to it. So if you took this orig.config.yaml and you wanted to rerun this just this one test, you could do that by manually blocking a couple, however many machines you need, and manually running Teuthology with just that YAML file. Talk a little more about the structure of these and what the contents mean later. Mike, look a little bit more at what the results of a job contain. Any questions so far?
Just yeah. So this is a repo, or can you able to clone this repo and then can we see the list of jobs, or how to see the jobs which are already available?
Yeah, so they're asking about like the test suites. The test suites are all in the Ceph repository itself. Let's take a look at that. So they're all in Ceph QA suites. You can see there's a number of different suites here. The primary ones are mostly based around the individual components. We have like Rados, RBD, RGW, CephFS, Ansible, Ceph Deploy. There are a few more generalized ones, like there's a power cycle suite, which we tend to not run too frequently unless we're doing a release, since it has some impact on the hardware. And there's a whole bunch of different upgrade suites for testing upgrades in different scenarios. Even within one of these folders, there's a number of different subsuites. So, for example, within Rados, there's a manager subsuite, there's a monitor thrashing subsuite, there's a general thrashing suite, which is basically randomized failures and randomized changes to OSDs. And you also see a bunch of these suites have a verify fiction, which includes things like valgrind and dependency checking. So, but in general, all you need to know to schedule one of these suites is just the name of the suite. So if I wanted to, I could just run the Rados suite here, just by specifying the name Rados. And Teuthology, when you schedule the suite, we'll go and check out a copy of the Ceph repository from the branch that you're scheduling against to get the suites from there. Generate the jobs from that, queue those jobs up, and then run those jobs with the packages that have been built.
Okay, so So to execute these scripts, do we need to have some special permission, or anyone can execute and see the results? So let us say if you want to, if I want to execute some of the test scripts which is already available, so what are the, I mean, is there anything we have to request or
So it varies depending on the tests, how easy it is to execute. A number of them can be executed outside of the Teuthology environment, but some of them are dependent on a Teuthology environment set up similarly to our stream test lab. So for example, if we take a look at one of these suites here. But I guess we can start looking at what this the structure of the two input files is here. So basically, the suites are composed of a number of YAML fragments that are all concatenated together and merged to form a list of tasks. So the general format of the input is a bunch of YAML files, or one YAML file, which has a list of tasks. And for example, this one uses this task called the work unit task, which basically just downloads some scripts from the Ceph repository and runs those shell scripts against a Ceph cluster that has already been set up by an earlier piece of this suite. So these work unit type scripts are an example of something that's very easy to run outside of a Teuthology environment. You could run these against a vStart cluster or another Ceph cluster that you already have set up. They generally only assume that you have a Ceph cluster with some kind of client key. There are some other tests that are more specific to Teuthology that actually use more code that's in Teuthology itself, and are kind of orchestrating the how the cluster is operating. For example, the thrashing subsuite. This is going to be a little more complicated in the thrashing subsuite because it's using mainly this thrash OSD's task here, which is part of run by Teuthology to orchestrate the cluster and inject various kinds of failures in the background while other tasks are going on. So this kind of test is more difficult to run outside of Teuthology. So going back to kind of what the overall configuration looks like, though, let's take a look at, for example, this original configuration. You already get that config.yaml file from this job, and that'll give you an idea of what's needed to run an individual test with Teuthology. So there's a whole bunch of extra stuff for these jobs scheduled through a suite. Most of this isn't necessary if you wanted to run a job manually. The things that are necessary for running a job manually are just a list of roles, which basically means these are just what's going to be run on different machines. So this means that you have one machine running mon.a, mon.c, and 3 OSDs, second machine running another monitor, a manager, and 3 OSDs, and a third machine which just has a client keyring created on it.
So that means the monitor, one machine, there are 2 monitors running and 3 OSDs are running, something like that?
Yeah, exactly.
Okay.
Exactly. And this YAML syntax is kind of funky with, this is actually a list of lists here. So the first indentation level is like one list. And there's a few different ways to write this. You could have, instead of saying like 2 dashes for a double list, you could say dash, and then you could have said mon.a, mon.b, etc. And more like a JSON style list, be a little bit clearer. So the roles is one aspect that you need. The second piece is the actual tasks to run. So typically for pretty much every test, you have the install task, which goes and installs Ceph packages.
So for RPMs, right? RPM packages.
Sorry, what was that?
It installs Ceph RPM packages, right?
It installs all the software packages for Ceph and its dependencies that it needs for some of the tests.
Okay.
And it'll install the version that's specified either as an option beneath the install task, or in this case, we've included it as a top level override section. So this override section is used kind of extensively within the test suite just to be able to add extra configuration to various tasks without having to kind of duplicate that configuration everywhere. You can kind of override one setting in one YAML file, and that it'll be combined later with another YAML file without having to duplicate that configuration. The general format of the overrides is that these all just get merged into the configuration of tasks. So everything below this Ceph label here would get merged into the configuration of the Ceph task. And similarly, in a little bit, we have an overrides for the install task, which is telling install tasks to add some extra packages that, namely RBD, NBD in this case, and which version to install. And this could be by SHA-1 or by branch name or by tag. The other task that pretty much every test is going to use is the Ceph task, which goes and sets up the Ceph cluster. So after the packages are installed everywhere, the Ceph task is the one who looks at the roles and sets up the monitors and the OSDs, the managers, and the client keys. So once that's in place, you basically have a Ceph cluster running, and you're ready to run whatever tests you need on top of that. For this particular test, it's using the thrash OSDs task to inject random values to the OSDs in the background. And while that's happening, it's going to run this RBD FSX workload, which is an RBD kind of stress test.
I have some questions.
Mhm.
If I submit a PR, for example, for Mimic or Luminous, and I
Yeah.
want to run these QA suites, should I indicate somehow that they should have to be taken from the Mimic or Luminous branch, or do the Teuthology takes that from that specific branch?
It'll take it from the same branch that you were scheduling against. So if you say, let's take a look at the schedule command what you use to run a suite. So to run a suite, in general, you'd use the Teuthology -suite command, and there's a whole bunch of options that it has. But the basics are that you would specify the I always like to run in verbose mode just for extra debugging. So I'd add actually you specify the suite to run. So you might run the Rados suite. Then you'd specify the version of the branch that you want to run against. So this might be, say, if you're doing a backport like whip luminous or something. And just by specifying that branch, it will if you run this after you run this Teuthology suite command, it will clone the Ceph repository from that branch to whatever you're running this command, in order to read the QA suite from that branch, and specify that job, that exact branch name in the jobs it's queuing up. So the packages from that branch will be installed. And also does some sanity checking. So if that branch doesn't have packages available, it won't schedule anything. It'll give you an error. So if it doesn't exist, of course, it'll give you an error too. So if I tried to run this right now, it'll just tell me this branch doesn't exist. One important.
Oh, sorry.
Well, go ahead before I continue.
It was a different question. I have a batch of questions that I've been
Okay.
writing down. So once a test fails, does it continue or it breaks in that point? And
it depends on the nature of the failure. So if there's a failure in a background sort of task, it will keep the foreground tasks will keep continuing until they're finished, and then it'll notice that it's failed at the end. But if it's running a foreground task, like it's running a bunch of functional or unit tests, and it fails immediately, then the job will fail. Across the entire suite, the individual test runs and jobs are independent of each other. So if one job fails, the rest will still try to run.
okay, so that explains why on failure, or the explanation affects a single test, right? I mean, there is no multiple failures within a single. Okay.
Yeah, exactly. And it's only really listing the first failure there. So the first thing that detects is wrong. So if there is like, for example, one of the things it checks is it looks at the cluster log at the end of the entire test to see if there's any errors that aren't supposed to be there. There's a wait list so that tests that are supposed to introduce errors can. But if something crashes before that, then the reason reported for failure will be that crash rather than something that is in the cluster log that may also be an issue. So it won't notice more than one failure in a given job.
So are logs as well as core dumps stored, or only the logs?
Yeah, logs and core dumps and whatever else is in this archive directory on the Teuthology node. So if you were developing a new test, as long as you were writing files to this archive directory, they would be gathered as well. Those all end up in for a given job in this remote directory. We have a directory for each machine, and then these are the that were gathered from that machine. So you have the syslog and the log directory, which has all the Ceph logs, basically coming from Borlog Ceph. And if there were core dumps, there would be a core dump directory there too. One other thing I wanted to mention about scheduling is that the way that these suites are structured, they're made out of many different fragments of YAML files that are combined in all possible combinations, basically. So there's kind of a combinatorial explosion of the number of jobs based on all those different, that giant matrix of different settings. What we typically do is we sample that matrix and only run a subset of it at a time. So for example, for the radar suite, if I tried to run the entire thing, it's probably like 100,000 jobs or something like that. But typically we use the subset parameter to run, say, where we can specify they run 1 out of 1,000 or 1 out of 10 or 1 out of 100 jobs. Not running all 100,000 jobs, but you're running a reasonable sample of them. And if you went through 0 through 99 out of 100, you would have run exactly every single configuration possible. Whenever I schedule a suite, I always like to do a dry run first, just to make sure I'm not going to schedule like thousands and thousands of jobs at once. And then you can adjust the subset as appropriate for a given suite. Suites don't need a subset because they're small enough that you can just run all the configuration in them every time. But the radar suite is one of those where you definitely want to restrict it. So it's just something to keep in mind.
The other day I started a run and I tried to stop it with the Teuthology kill command, and it seems I had it previously and it worked, but this time it's required me to use sudo. I'm not sure why, so I couldn't stop this task.
Yeah, so Teuthology kill does a few things. So how these end up running eventually after jobs are processed and pulled out of the queue, they're run by a different worker on this machine, a different Unix user. So you would need the sudo permissions to be able to kill those processes from that other user. Whereas if there are tests that are in the queue already but they aren't running yet, then you don't need any special permissions to remove them from the queue. The Teuthology kill command will both remove things from the queue and try to kill running processes too.
Okay. So for the selections of machines, is there any suggestion on when to use Smithy or Mira or?
But I guess in general, if you are doing some kind of performance-related tests, it's more important to figure out what you want to use. Smithy is all SSD. Mira is older hard disk hardware. And you also want to take into account you can kind of look at the current state of the queue in Pulpito and see what's already queued up, and oftentimes there's a whole bunch of like automated runs waiting for Smithy machines, but you can schedule against mirror machines, and your test will kick off faster. If you do have something very urgent to run, you can add the priority field and run a test with, say, priority 100, which will which means that your test will get run before the automated jobs, which I think are scheduled at priority 1000. So if you have anything urgent, you can do that. Your test will kind of go to the front of the line. Smithy nodes are much faster because they're all SSD. So if you do something urgent, I would recommend using them.
I've also seen that some tests are flapping, or if you have a look at the runs, the number of runs in red are by far, much more than the green ones. So is this? There is some, agreement on when a run can be considered as fast or fail, depending on which tests are failing?
Yeah, so there are certainly, in a large system like Ceph, there's lots of race conditions especially, and some of those are very difficult to fix or reproduce. So there are some like known issues that we'll see very occasionally, and it'll often be that they'll present with the same kind of backtrace or failure mode, and you can search in the tracker for that exact failure and see that, okay, this is a known issue. It's unrelated to my change because it's in a totally different system that's unaffected by it. And there are also occasionally failures from the lab infrastructure or from GitHub. Well, you'll see some things like, if you see something like packages failing to install because the mirror is timed out, that's obviously not the fault of your code. Or if downloading a test from GitHub fails because GitHub went down or decided to rate limit us for some reason, then that's obviously not a failure of the code either.
So every time it will build the package and it will install, or how it will install? If you take from the repository directory.
It's installing stuff from the packages, but for some of the tests, it's downloading some scripts from GitHub to run the test.
Okay. So that means it will take the packages from the existing repository and not from the, but how it will then uses the current branch. So
when you're scheduling, it tells you tell it which branch to use, and that's when it goes to install the packages. It goes and looks up that branch in Shaman. Shaman has an API that it uses to find out where the repositories, where the packages for this branch are.
okay, good.
So it configures the machines, whether they're CentOS or Ubuntu, to use that repository and installs packages from there.
Are there any guidelines on, how to relate the changes one developer has made and which should he run or?
Yeah, so I guess in general, changes tend to be made either to a few different areas. So like I was mentioning before, there are kind of suites few different areas in Ceph, like the suites for RBD or CephFS or RGW. And for example, within the radio suite, there are ones for more specific to the monitor or more specific to the manager. But if it's something that may affect multiple systems, then just running it through like a subset of the radio suite, or if it's a common code that's used by like RBD and CephFS, running through both those suites makes sense.
Just out of curiosity, have you ever run a coverage test to check how, deep this end-to-end testing is covering the
Yes,
source?
a long time ago, Teuthology had support for collecting code coverage data as well. We didn't really find it that useful, unfortunately, since it didn't relate very well to functional aspects that were not covered. So it's kind of bit rotted since then. And at this point, I'm not sure exactly what the coverage ratio is. Maybe we should look at if something fails, where to look to figure out why it failed. So the most basic failure reason you can see in Pulpito just lists the like the last crash or the log line that was not expected, and that's a good place to start. But to see where that came from, or if it's a command that failed, for example, to see why that command failed, you want to look at the Teuthology.log for that job. So whenever I open a Teuthology log, the first thing that's failed, the first thing I do is I search for traceback, because that's and so whenever there was a failure, usually it's due to like a command failing or something, and it generates a traceback in the Teuthology log explaining exception why this failed. So in this case, we have a command failed error, which is pretty self-explanatory. It was running a command, and that command exited non-zero. And in this case, you may see like a bunch of kind of boilerplate for Teuthology. You can kind of ignore this adjust limits coverage stuff. That's kind of the coverage stuff in particular is a relic of the code coverage that doesn't really function anymore. And then you have the actual command that's run, which in this case is the Ceph test of RBD FSX RBD stress test. So because this is a stress test, you can kind of look back a little bit through the log and see where this test was last running and what it was doing at the time it failed. So basically, we get the standard output and the standard error from all these commands that are being run. And this particular case, I'm familiar with our RBD FSX test, and this is the output from it here. So you can go back up and see more about where it started to fail and exactly what it was doing when it was failing.
Hey Josh, if you unfamiliar with that particular test, how do you correlate to the output?
Yeah, so that's a good question, because a lot of these tests you would have to be a bit familiar with what they're doing to understand what their output looks like. A few of them, like the API tests and the more generic functional tests, are using kind of unit test frameworks, so you can often search for like the word failed or error to see where that unit test framework reported a failure and which test it was reporting a failure with.
Another trick is once you're at the traceback, is to search backwards for Ceph version. So if there's a crash, an assertion failure, or something like that, it'll usually appear in the log just above where the command errored out or whatever.
Yeah, that's an excellent point. So in this case, it's just a test command that doesn't do a backtrace like that. It's not part of the main Ceph code. But if there was a backtrace from like a Ceph daemon or something, searching for Ceph version is a good way to find that. Let's see, was there a good example of that in this run? Okay, maybe it's not a great example of that in this run. Let me go to a different run real quick. Okay, here we go. The run that showed the failure reason as you can also look at the failure reason in this summary.yaml file in each of these output directories. This is the same thing that's displayed in Pulpito, and it reports it something times out waiting for an admin socket to appear after OSD.3 restart. And this typically means that OSD3 crashed, which it should be a traceback either in the Teuthology log or in the OSD logs themselves. Looking at this, I would search for traceback to see where it failed. In this case, there's one exception while it was reconnecting the machines, which didn't cause the test to fail. That's just a retry afterwards. And here's where I got that error, waiting for the OSD3 to restart. If we search backwards from here for the version, we get this backtrace from the OSD showing which assert we're hitting and where that came from. Going back to that point, it's worth noting in the logs here for the daemon output like this, the prefix for each log line includes which daemon this is coming from. So you can tell this is from OSD3 and it was running on Smithy 145. So then if you wanted to investigate further, you could take a look at the remote directory for Smithy 145. And you'd see the core dump there. And running the file command on it confirms that it came from Ceph OSD number 3. You can then look at OSD3's log, and going to the end of that log should find that same traceback. The version. In this case, it looks like the OSD was not able to finish logging the traceback before it crashed, so it does not appear in the OSD log itself. But it did in the Teuthology log, which is often good enough. All right, any other questions so far? I think we've covered a lot of different things, and I'm sure there's
Yeah, I have
things
another
that
one.
could be explained clearer. Yeah.
I assume that when a test fails, the cluster is decommissioned. So if is there a way to stop that, to break the test there and, I mean, log in and have a look at the environment?
Yeah, so for all the jobs that are scheduled through the suites and queued up, there's not a good way to do that because that would keep those machines around and unavailable for too long. And if you ran a suite that had a whole bunch of failures like that, it could just lock up a whole bunch of machines for a really long time. Instead, what we usually do is we would if there was some kind of crazy bug like that where we need to go and investigate interactively, we would lock a couple machines manually, run that same YAML file that for the job that failed manually on those machines, and when you're running manually, there's a parameter you can add to your YAML file called interactive on error. If you set that to true, then the job test will pause when it hits an error, and you can go and inspect the machines at that point. So let's do a quick example of that. So to run something manually, first what you want to do is lock a couple machines. We can just say run a simple test on one machine for now. So to lock a machine, you use the Teuthology-lock command. Post form is just saying lock many, say how many you want to lock, say one, and you can say I think it's machine type. So say we lock a Mura. And they'll go ahead and output the machine that you've got locked and the host SSH key for that machine. And this is something that you'd have in it, you want to put in a YAML file that you'd run your test with. This little YAML file here. Of the machine that we're going to run on. I have some roles for that machine. It has a couple OSDs, monitor, and a manager. Client. And then we need to ask, so let's say we want to install, want to run Ceph, and if you have a test you want to investigate manually, you could say interactive on error true. If you're kind of developing a test, you could also there's an interactive task which just goes into a Python shell, and until you exit the Python shell, everything else will just be paused and running in on the machines. So if we try to run something manually, use the Teuthology command itself, which is something that ends up being used by the workers when they're taking things off of the queue. This has a relatively small number of options, at least. Typically, you just want to specify verbose modes to get more debug output if something goes wrong. You want to say, if you want to save the log files after the test is complete, as well as the output from the Teuthology command itself, you can add an archive directory. And then the other thing you need is your YAML file. Since we have all of our information about this test, both the machines that we're going to use, the roles that are applied to those machines, and the tasks in one file, that's all we need. If we had those more than one file, we could specify more files here. Now here we run into a consequence of running against master and stable branches. So running against master and stable branches is slightly different because master and other stable branches aren't in the Ceph CI repository. They're in the regular github.com Ceph repository. So in our YAML file, we'd want to either install our testing branch or change the repository that we're going to use so that we can leave its Ceph repo. We can use a stable branch in this case, or master. And just to confirm that which variables this is, we need the suite repo too, I think. We can take a look at an existing job like this this one here. So the specification is actually repo for the packages, and then suite repo for where the tasks are grabbed from. And if this archive directory already exists, it'll stop it. So I just remove it first. There we go. So it's going to install Ceph packages, or apparently it's unable to connect to this machine. So looks like this machine may not. Let's see. So as you can see, it's falling into a Python prompt here. This is an example of one of those failures that would cause it to go into interactive mode. In this case, since it failed to even connect to the machine, there's not much I can do. I'm just going to Control D out of that Python prompt and end the test. So let's see what's happening here. I try manually SSHing into that machine. And there's no root to host, so it sounds like that machine is dead. I'm going to use a different machine and mark that one down.
When you specify, when I'm usually locking machines, I specify the distro and I have to wait 10 minutes for Fog to go and image it. When you did that one, it just gave it to you right away. I wonder That's because
Well,
it
it's
just doesn't
usually
specify.
queued up. If it's not specified, I think it uses the default of I forget what the default is. Maybe Xenial.
But you didn't have to wait. Sort of weird. I'm wondering if
Yeah,
the behavior changed recently. If you don't specify distro, it doesn't even image it or something, or it just gives you what
that
it
would be strange.
You can add lock on command line and not to lock machines manually altogether, just to avoid it.
Bad too. Yeah, so we can also, like Yuri suggests, use the lock option to have the Teuthology go ahead and lock a machine for us at the beginning of this test instead of manually specifying it. Let's try that. I'll look out the
You don't need
section.
to unlock them right after you use it, right?
Yeah, it'll clean up right afterwards. So you want to make sure you have interactive or interactive on error so you can actually go inspect it if you do that. Also, I think you have to specify OS version and OS release. Yeah. And machine type.
Does block do?
Or OS type and OS version.
Oh,
Okay. Lock
actually,
tells it to lock
never
machines.
specified
Lock.
version.
Never specified version. Okay.
No, I
Yeah,
think it'll be by default Ubuntu. I think that's my.
Yeah.
And machine type.
So lock will lock a machine at the beginning here and unlock it when the test exits. Maybe the mirrors are having problems right now. Let me try Smithy. Block will wait until there's a machine available if you can't lock one immediately. Having trouble connecting to this one too. Seems strange. Okay.
I haven't actually tried doing this in a long time. I always just schedule it through the suite.
That bug that Keifu was working on, like from MimicX, I ran that interactively like a day ago.
Okay.
So it's fine.
Yeah, maybe there's a problem with the lab cluster right now then, or something. Maybe just this Teuthology box. In any case, that's basically the way you can run something interactively and go and inspect what's going on. If you're unsure exactly what it's doing, it's also worth maybe pointing out where these tasks live. So there are kind of generic tasks that live in the Teuthology repository. So they're in Teuthology/tasks. These are all basically just Python files, and still either have a task method or they will be a class with a setup and teardown, which is their entry point, and the doc string for that task will have information about what kind of options it has. And so, for example, this is the interactive task. It's just a single task method, which doesn't have any options. And it simply runs a Python interactive prompt. More Ceph-specific repository under the QA suites, they're under QA tasks. Here you'll find things like the Ceph task that installs the Ceph cluster. You search for a def task. You can see a whole bunch of options that you can specify. Like for file store, you could specify which file system to use. And you can add different configuration settings that would be added to the Ceph.conf file, that kind of thing. But in general, if you want to see more about what exactly is going on, you can go and look at what these tasks are doing, what options they take, and go from there. So I think that's been about everything I wanted to cover today. I'm sure there's still lots of questions, and feel free to reach out to me after this as well if you have any other questions. Any questions right now?
Yeah, I have my two last ones. Are we gathering some metrics for the runs? I mean, the CPU consumption, memory, or even Ceph-specific metrics?
Yeah, so we at least used to be gathering a bunch of those into Grafana. I'm not sure that still is working anymore. We do have a performance suite, which they added just last year, which does gather more of those that stuff based on like using collectl. But in general, that's an area where we could improve quite a bit. For example, it would be awesome if we had like the historical data from a run that we could see in the Ceph metrics type UI after the run is complete. We could say, okay, at this point, we're using all the CPU, and this is where memory exploded during recovery, or that kind of thing.
And my very last question is, I've seen this Sentry platform. What is this? Is this something that is going to be migrated to, or?
I'm not sure. I don't really use that Sentry myself that much. I don't find it that useful. I'm not sure if others do. I think the idea is that it's supposed to collect failures and show you when you've seen the same failures. But I think in the past it hasn't been that helpful to me, at least.
Thank you very much. That were my questions.
No problem. All right. Anybody else? Okay.
Thank you, Josh.
No problem. And like I said before, feel free to reach out to me if you have any questions in the future. And this recording will be sent out once it's available. Thanks, everybody.
Thank you very much.
Bye-bye.
Bye.
Bye.
Thank you, Josh. Thanks. Bye.